So 2.2 is subsets. Subsets. So let's just talk about conceptually what a subset is. So first of all, you guys are my set of 9 a.m. students, right? A subset of you, today, if I handed out the roll, not everybody's here. Who's here today in class is a subset of my original set. Now, on test day, when everybody shows up, everybody's here, but it's still a subset of my original set. So even though all of you are on my roster and all of you show up, we would still call you a subset of my original set. I could also make a subset of just, let's say just the front row shows up next week. That would be one subset of the original set. We can say, oh, wait, how many of you were here yesterday? Well, none of you. So the empty set is also a subset of the original set. And all the different combinations of who can show up any given day is a subset. So let's not have that many elements when we're trying to list all the subsets. Let's just start out with, let's say, A, B, and C. And let's go ahead and list all the subsets of A, B, and C. So the first one, I could say A is a subset. I could also say B is a subset. C is a subset. And I could do some combinations. I could say A and B. That's a subset. A and C. And B and C. And as we just talked about, we said that the empty set was also a subset. The empty set is a subset of every single set. You always have a subset of the empty set. We also said the set itself, A, B, C. So for these three elements, I found 1, 2, 3, 4, 5, 6, 7, 8 subsets of that set. The notation for subset. The notation for subset is A is a subset of A, B, C. I use these braces to represent a set being a subset. It's like a C with an underline. Set A is a subset of this set ABC. Since we defined ABC on the other page as being capital letter A, I could also write it as A is a subset of capital letter A because capital letter A was defined as the set ABC. So I could write these either way. Now, I didn't show the notation for element too much. I kind of passed that over. So let's say I could say A is an element of A. What's that mean? That means this little a, here, let's put this up here again. A we defined as A, B, C. We defined that. So I could say A, this little, is an element of that set. I could also say 1 is not an element of A because 1's not in there, right? What I cannot say, A is a subset of A because sets are subsets of other sets. This capital A is defined by this set. This doesn't have any braces around it. That means it's an element. You can't combine an element with a set using subset notation. That's where this notation comes in. This says an element of a set. So I could say this is true. I'll say this is false because not the proper notation. Is A an element of this? This is true. 1 is not an element of A. Is that true or false? That's true. Key here is that sets are combined with other sets, using the subset notation. Elements are combined with sets using the element notation. Okay, let's go back to all of these. These are subsets. And this is my notation. Let's talk about proper subsets. What's a proper subset? Let me show you the notation first, and then let's see if you can figure it out. So this is a subset notation. This is the proper subset notation. What's the difference? The line underneath, right? In inequalities and equalities, what's the line underneath represent? When it's equal to. It represents the same thing here. It says, basically, the proper subsets are all of these subsets, except for the set itself. So when I talk about proper subsets, I'm referring to all of these in the box are proper subsets, except for this one. So it's just one less. So if I tell you there's 100 subsets, you're going to tell me there's how many proper subsets? 99. There's just one less. It's all of them except for the set itself. Okay? And you remember the notation, you can get yourself to remembering that. It's all of them except that one. The way the book asks the question, what they'll say is they'll say use this symbol, or both. So what would make it true? San Francisco, and I put this line underneath, meaning you got to fill in the blank, okay? And I say California. Is San Francisco a subset of California? Yeah, California is big and San Francisco fits in it. The way I read this is I always used to read it contained in. Is San Francisco contained in California? Yes. So that to me is a subset. Now, let's ask ourselves, is this true? Yeah, because it's a subset. That's a proper subset notation. San Francisco is not equal to California, so that's true, right? So then I say, well, is this true? Yes, that's true too, because remember, this represents all the subsets and the set itself. So they're both true. Okay? So this answer is both. Before I put another one up here, let me ask you, would it be true to write this? Could I say California is a subset of San Francisco? No. You can't, because California's huge, right? Can you fit all of California into San Francisco? And it wouldn't be a subset. That's why when I say it, I say contained in. So if you think of the subset as contained in, I say California is not contained in San Francisco, but San Francisco is contained in California. Okay, let's do another one, because this is a good time. The set A, B, C, and then I draw this line and all this B, C, A. Can I use this notation? No, because they're exactly the same, right? They're exactly the same, so I cannot use the proper subset. Can I use this one? Yes. Now, look at this just like the other one. So if they're equal, you're using the subset notation, right? Because you can't use the other one. But if they're not equal and they are a subset, is there any time you're going to use this without using this? If they're equal, this cannot work, right? If they're equal, this cannot work because it doesn't have the equal sign under it, so it can't work. But if they're not equal, this will work, and so will this. They don't have to be equal for this to work. Think of it as a inequality. You know, an inequality represents the value that's equal and all the ones to the left or right of it. There's just one set difference between these. So the proper subset notation is going to work for everything except for the set itself. The subset notation is going to work for every subset. So the only time that these are not both, it's when it's equal. Okay, if I have no elements, so I have, let's say, n equals number of elements. There. And then let's say over here we have number of subsets. So if I have 0 elements, how many subsets do I have? I have 1, because the subset, the empty set is a subset of every set, right? So I have 1 subset. If I have A, how many elements? 1. How many subsets? 2, because I have the set itself and the empty set. So I have 2 subsets. If I have 2 elements, let's say A, comma, B, 2 elements, well, let's look at those just real quick. That would be the set A, the set B, then A and B, and then what else? The empty set. So how many do I have? So I have 2 elements, I have 4 subsets. 3 elements we already listed out, right? When I have A, comma, B, comma, C, I have 3 elements, 8 subsets. If you follow this pattern, this increases by 2, then this with 4 elements to the n is your idea. So when there's 0 elements, 2 to the 0 power, does that equal 1? Yeah, anything to the 0 power is 1. So let's say 2 to the first power, does that equal 2? 2 to the second power. 4, yep. 2 to the third power does equal 8. 2 to the fourth power. Yep, 16. 2 to the fifth is 32. So you can find the number of subsets. If I have 5 elements and I know I have 32 subsets, how many proper subsets do I have? 31, because it's just 1 less. So the formula for subsets is 2 to the n. That's the number of subsets. The number of proper subsets, I'll just write it, proper is 2 to the n minus 1.